Okay, so this section, x to the 1/5 power. Isn't that weird? What does it mean to put a fraction in the power zone? Isn't that strange? You guys know what powers mean. Like what does x to the third mean? That means x times x times x, right? 3 of them, right? Whatever number you put in the upper right-hand corner, that's how many multiply together. It's a repeat symbol, isn't it? It means that many. So what in the world does it mean to repeat 1/5 of them? What does that even mean? Yeah, I guess 1%, huh? Anybody know? There's a special rule. Anybody seen this before? I don't think we did this in 201. Not a decimal. It changes to a root. That bottom swings around, goes in the hook, and the 1 stays where it was. It's the 5th root of x to the 1, which is just x. And that's our answer. That's all they want for now. Does everybody see that? Isn't that strange looking? The denominator swings into the hook. Have you seen that before? So basically the rule is this. Let me write out the rule here. Here is the rule. When you have a fraction power, a over b power, that b swings around into the hook and the a stays put. So the x to the a is still x to the a. That didn't go anywhere. But the denominator, whatever's under the bar, swings into the hook. Like that. Does that make sense? It swings around and ends up in the hook here. From denominator, swings into the hook. So that's what you got to remember. I think I watched way too many cartoons when I was a kid. I always think of Scooby-Dooby-Doo, and he would run and fall in a trap in the intro theme music. Maybe you guys never watched Scooby-Dooby-Doo. But if that helps you, I'll mention it. I always think of it when I see this for whatever reason. It's like Scooby just falls. So the denominator falls and ends up in the trap. So that's what happens. That's what happens with the denominator power. It falls down, swings around, ends up in the hook, in the little trap area. And that's it. That's all they want for now. They just want you to basically what we're learning is how to say the same thing in 2 languages, like saying 1 and uno. I'm saying the same number, 2 languages. You can say x to the 1/5, or you can say 5th root of x to the 1. You're saying the same thing. This is fractional power language. They call that rational. Rational means fraction. Rational power language, rationals. And this is radicals. That's the name for roots, radicals. So it's the same thing said in 2 different languages. That's what we're looking at. Now they're going to put a number there. So 16 to the 1/4 power. So what happens with that 1/4? How do we change that fraction power thing into a root thing? Where's that 4 go? Scooby-Doo falls down into the little hook there. The 16 to the 1, that stays the same. 16 to the 1, just 16. Good so far? Now, what is the 4th root of 16? What's a 4 in the hook mean? Like that. What does that mean? Basically, if you broke that 16 down, it'd be 4 times 4, and each of those is 2 times 2, right? So that's the 4th root of 2, 2, 2, 2. You good so far?
And for every 2 you get inside, 1 goes outside.
Yeah, normally, we do a 2 for 1 deal with roots. So guess what we do when there's a 4 in the hook? A 4 for 1 deal. It's even a better deal at Target. It's a 4 for 1 deal. You with me on that? Normally there's nothing in the hook, right? What's the square root of 9? I want to show you that this is not something new. It's what we've been doing all along. Right, that's the deal. Square root of 9 is 3. We all know. Why? Because there's really 2 3s in there, and 2 3s in make 1 3 come out. Why? Why do we do a 2 for 1 thing here? Because there's really a 2 in there. When we don't show anything in the hook, all along, when we haven't been showing anything in the hook, there really is a 2 there, and you should know that. Why? Because of what you call it. What do we call this? Square root. What does square mean? What is this called? X2'd? It's called x squared. So what does square mean? 2. What's the word for 3 in math? Cube. Cube's 3-dimensional. Square is flat, 2-dimensional. So whenever we say square, we're using a word for 2 in math, aren't we? So when we call this a square root, when we've been calling it square root all along, we've been saying it's a 2 root. Right? Because square means 2. Right? X squared, x 2'd. So square root, x squared, square root means 2 root. So that's why I'm saying you should know there really is a 2 there. Because we call it a square root. We call it a 2 root. And that's why 2 in, 1 out. So if they put a different number in there, I don't know what you'd call it, a quad root, I guess, whatever. Nobody says that. You just say there's a 4 there. So what do? It's a 4 for 1 deal. 4 2's in, 1 2 out, and the root's gone. Because everything left the root. Right? It's a 4 for 1 deal.
So if there was a 3?
Yeah, what if there was a 3? Good question. What if there was a 3? Well, then 3 of them would come out, and 1 would be left in. Well, and it always comes out as 1. Right? It's like a target. If you're buying something 3 for 1, you just pay the price of 1. So these 3 would send 1 out, and the extra one would be left in. If it was 3. But it's not 3, it's 4. So they all 4 come out as 1. You pay for 1 to get 4. So that makes it like a
If it was just 3, the 3 would stay, the root.
Oh yeah, we never change the hook number.
Okay.
Yeah, that always
Unless
stayed.
it all comes out.
Unless then the whole root vanishes. But if the root's still there, we keep the number in the hook that it'll always be a 4th root or 3rd root or whatever it is. Yeah. Is that good? Does that make sense? So the answer to this problem is 2. That's 16 to the 1/4.
So you said 4 for 1.
It's a 4 for 1 deal. So it's like you're shopping at Target. These things are on sale today, 4 for 1. What does that mean? You get 4 of them, go out of the store, and you paid for 1. Right? That's exactly what happens. Only 1 comes out representing the price of 4. Or, you know what I mean. I'm saying that kind of backwards. Do you remember, let's recall, before we do this particular question, let's recall the other power rules. If you have like 2 to the 3rd, rule number 1, 2 to the 3rd times 2 to the 4th, what does that equal? 2 to the 7th. You add them, huh? Remember that rule? Okay. But what if you have 2 to the 3rd with parentheses to the 4th? You multiply, right? Powers, I'm scribbling. Powers outside parentheses, multiply powers inside parentheses, right? So this power multiplies that, right? So if we have a to the 8th, b to the 8th, all to the 1/9, that power goes boom, boom. Powers outside parentheses, multiply powers inside, and what do you get? A to the 8/9, b to the 8/9, we're done. See, that's the same thing I'm doing here, right? Just like that, 4 multiplied that 3 to be 12. So that 1/9 hits it, because 8's over 1, right? You guys with me? Those are 8 over 1, 8 over 1. So when 8 over 1 multiplies 1 over 9, it becomes 8/9, doesn't it? You with me on that? This is what really just happened in each of those power interactions, right? 1 over 9 hit 8 over 1 to become 8/9. For each of those. Powers outside parentheses, multiply powers inside parentheses.
I just did that question and it had it would be 9 Radican.
Oh yeah, sorry. I mean that's true, but they don't want you to do it that way on this. I'm kind of doing something we're gonna do later. Sorry, I should read the instructions. Write without rational powers, and I made it rational powers. So they want the root thing instead. My mistake. I didn't read. I forgot what we're doing. We're in the root chapter, aren't we? So let's go back. I mean that's true, but that's not the language they wanted in. So a to the 8th, b to the 8th, to the 1/9. All that's all true, but what they want instead is the 9 to swing around. They want the 9th root of a to the 8th, b to the 8th, and we're done. That's all they want for now. That other stuff's coming later, so we'll do it. But is that good? Remember the Scooby-Doo denominator swings around into the hook. Where'd the 1 go? Well, 1 power doesn't change anything, huh? So it just vanishes. Does that make sense? So whenever you have a fractional power, Scooby-Doo, the denominator falls through the trap door and swings around, ends up in the little trap, the hook.
So it's just 9?
Ninth root of, and the inside hasn't changed, a to the 8th, b to the 8th.
So the 1 just like went away?
Yeah, because what is x? What is x to the 1? Just x. Right? Anything to the 1 power, we ignore 1 powers. Because anything's to the 1 power. Is that good? So the number in the denominator swings in it. I mean, you could say this is all to the 1 power if you want, but that won't change anything, right? All right. So 625 to the 3/4. Yeah, that's hard. All right. So what's that 4 do? That Scooby-Doo falls down in the trap door into the trap. So far, so good? The 3 just stays put. Now, we have 2 things we need to do here. We need to do the 3rd power on the 625, and we need to do the 4th root on the 625. Easier to do, you can do them in either order, same answer. Let's do this first. This will be way easier. Let's do the 4th root part first, because that'll make the number smaller, and then we'll do the 3rd power afterwards. So first do the 4th root. How do you do the 4th root? Well, you got to take the 625 and break it down. You guys have your calculator? What goes into 625? Clearly 5 at least, right? Because it ends in a 5. So use your calculator, divide by 5, and you'll find out it's 5 times 125. And then that'll divide by 5 again. That's 5 times 25, and that's 5. So you'll see that 625 breaks down to be 4 5s. So what we have is 4th root of 5, 5, 5, 5, and then that's all going to be to the 3rd power in a minute. But, well, in fact, let me not even rewrite it this way. What do you do? What do you do with these 4 5s? Yeah, because it's a 4 for 1 deal. Remember? The number in the hook number makes it a 4 for 1 deal. Out. So 4 5s in, 1 5 out of the root. The root vanishes, but the 3rd power is still there. We haven't done him yet.
Oh, okay.
You with me? We good so far? Everybody good to that point? See what happened there. The fourth root of 625, 4 5s in, 1 5 out, root vanishes, but the 3rd power is still there. We haven't done him yet. 5 to the 3rd, just use your calculator. 5 times 5 times 5, 125. There's the answer. Is that good? Now, the other option is to do it all on your calculator, which you'll probably like this option. Calculator, just take 625 to the power. Now, power buttons are different on different calculators. You might have an up arrow, or you might have like an X to the Y button to the power, and then you've got to go parenthesis 3 divided by 4 parenthesis equal. Depending on you, some calculators you don't have to. Anyway, type that in, see if you can get 125. So 625 to the power, parentheses 3 divided by 4, equals. You should be able to get 125. Is that working out? So you still have to know these rules because in a minute they're going to put X's instead of numbers. But for the pure number ones, you can use your calculator. Is that working out? Did your answer come out?
Oh, I did it your way.
Yeah. So try it the other way too. Make sure you can do it with your calculator also. Is that good? Is it working? Is it working? Anybody not getting it? Is it not working? I can do like a demo if you do one of them on a demo. If it's getting, Kara, is it working out?
No, I don't.
Yours problematic here. Can you pass yours up and I'll maybe that one is a little difficult. Could you grab that from Kara? Thanks. And I'll throw it on the Elmo and see. because other people think you have this same one. And this one is a little difficult to remember, right? So, let's see. Okay. So, so what are we doing? 625. 625 to the power button's right here on this calculator, the up arrow right there. To the power, that's the problem, of parenthesis 3 divided by 4 parenthesis equals 125.
Which one is it? The one that has like a little X?
That up arrow, yeah, that up arrow right there. That's the power.
I can do this.
That good?
What if we calculate this and have that little button?
Yeah, so some calculators have the X to the Y button. And they almost always have one or the other. Okay, next one.
Mine's sharp.
Yeah, let's see. This one has, what does it have? Oh, right here, it's y to the x. Yeah, they're doing y to the x, y. So you would just go, what is it, 625? 625 to the power, I just hit it. It doesn't show anything, but I did. 3 divided by, oh no, I forgot the parentheses. Yeah, 625 to the power. Now watch what I'm going to do. Parenthesis, 3 divided by 4, parenthesis, equals. Yep. So exactly the sequence I wrote out. It's exactly the sequence I wrote out. Did yours do the same thing? X to the y? Let's see. So is there x to the y somewhere? Oh, right here. Y to the x. There it is right there. There's the power button. So it's going to be the same exact procedure. 625, y to the x. Boom, I hit it. Parenthesis, where's the parentheses? Oh, right here. Parentheses over here. Parenthesis. 3 divided by 4, parenthesis, equals. Exactly the same. So when I say that, let me show you again the sequence I wrote out.
So when I get to university, they're never gonna make me go backwards and do this by hand.
No, we'll do it by hand with X's in just a little bit. So there it is. So this exact procedure I wrote out. 625, one of those power buttons, parenthesis 3 divided by 4, parenthesis equals. That exact sequence for your guys' calculators will work. That's that. All right. Let's move on. If y'all got that down. All right. Let's try this one. 9 to the, go ahead and just use, if it's pure numbers, you can just use your calculator. If there's X's, you're going to have to do the by hand rules. So try that one. Should be 243. 243. Just getting that in your calculator. 243. I'll show it by hand just for fun. It'll be fun. The 2 root of 9 to the 5th, right? Scooby-Doo falls through the trap door. 2 root of 5 nines, 3, 4, 5, right? And then what does the 2 in the hook mean? 2 for 1 deal at target. 2 nines in, 1 9 out. 2 more nines in, another 9 out. What comes out? 9 times 9, what's left in? The other 9. Good so far? And what's 9 times 9? 81. What's the square root of 9? 3. 3 times 81, 243. So by hand or by calculator? It's 243. Everybody see what I did there, right? Scooby-Doo went in the hook. 5 nines, 2 nines in, 1 out, 2 nines in, 1 out. They're all gone. And there's only 1 9 left in. Right? Remember, the 2 means 2 for 1 deal. Now, you might want to miss it. Shouldn't you break that down to 3 through the? You could. You could do that, or you could just do the nines. Either way. 2 nines made it out. 1 representing those 2, the other representing those 2, and the 1 left over is still in. 9 times 9 is 81. Square root of 9, 3. Multiply, 243. So by hand or by calculator? So, square root 19. What do they want me to do? Hit the buttons, get a decimal? No, they're actually saying rewrite with rationals. Remember, if you're not sure, remember how to, because this can be one of those sections that's confusing. You're like, what do you guys even want me to do? You try putting in a decimal and it doesn't like that. Remember what to do if you're ever unsure what they're saying? What could you say? Actually, they are. Rational. What does rational mean? Fraction. What's the exponent? Power. They're saying fractional power in their language. They're saying, give me a fractional power, please. I don't want this root. give me a fractional. So we're translating. We're going from uno back to one now. We're translating between the two languages. Remember the two languages. Fractional powers or roots. Back and forth. Okay, how do you do it? Scooby-Doo's going to come out of the trap. So what's in the trap right now? I don't see anything in the trap. 2. Remember, if nothing's shown, it's called a what root? Square 2 root. And there's no, I don't see any power on the 19. So what power is really on the 19? 1. 19 to the 1 is 19. So let Scooby-Doo come back. See, that's the same thing. See how that's the same thing? Right? The 2 could go back in the hook, and it'd be the 2 root of 19 to the 1. And the 2 and the 1 are both invisible, really. You don't show the 2 in the hook, and you don't show the 1 power. They're both understood to be there. We have a lot of invisible understood things in math, don't we? It's just because that's the one used most commonly. So after a while, they said, look, I don't want to write the 2 all the time. If I don't write anything in there, you know I mean 2. That's what happened over time. 2 is just used most commonly. Is that good? Does that make sense how I undid the root, went back to the fraction power language? And you see now you speak this a little better. See that they were asking for fractional power. Okay, so we have the 5th root of x, y squared, z. So what am I going to do with that? They want me to go back. Again, they want fractional powers, don't they? So what am I going to do with that 5 in the hook? Scooby-Doo's coming out of the trap. It'll go to denominator, right? Hook is denominator. So it's really a 1/5 power, isn't it? You with me? So it'll become x. Well, let's just do it this way. It'll become x to the 1/5, y to the 2/5, z to the 1/5, done. Do you see how it put a 5 denominator power for x, y, and z? Because the root was over all 3, x, y, and z. So the 5th root is a 5 denominator power for all 3. And the y already had a 2, so he keeps his 2. But the x and the z, they just have invisible 1s. Does that make sense? Fraction powers, roots, saying the same thing. 2 different languages. So they're making you more proficient in these 2 languages. Good. We're learning Chinese here. So we have the root of 7mn all to the 7th. Same thing, they want you to rewrite in fractional power. So get rid of that root, in other words. Get out of the root language, the radical language, and turn it into fraction power language. Can you do that? So, what's in the hook? I don't see anything in the hook. 2. Where does he go? Denominator. So 7mn to the 7 halves like that. Does that make sense? Do I need parentheses or can I just leave it like that? Like parentheses like that, would that be good? No, that's totally wrong. Why? Why is that so wrong? What? Right, it's outside, but why is outside a problem? Let me ask you this. Who's the root over? Everybody. The 7, the m, and the n. The root is over everybody. The power is over everybody. So therefore, the fractional power needs to be over everybody, which is like this, isn't it? See, that means the fractional power is on everybody now, doesn't it? Which is consistent with the original root being on everybody. See how that's true to the original? But if I put the parentheses outside, you know, that power is only on the end now.
So if there wasn't parentheses, then all of them would get 7/2 and then 1/2 and then 1/2.
So well, hold on. Let me first answer this. Everybody see that is wrong because then the 7 halves is only on the end, and it was on the root was on everybody from the beginning. So the power has to be on everybody.
Yeah.
Everybody see that? Now Abraham's question is, if the root, what did you say about the root of the 7 or the parentheses?
Wasn't there.
Okay, so if we just had the 2 root of 7mn and just had the 7, well, I'm not even sure what that 7, nobody would write that because what is that 7 exactly on? Is it on the end? Is it on the root? I mean, what is that thing on? So they would put parentheses to say it's on everything. Or if they didn't want it on everything, if they just wanted it on the n, then they would put it right there on the n.
Okay, because the number 7, it just had the x, y squared, and z, and then you just added all 1 over 5, right?
Right.
So that's why I was.
Oh, I see what you're saying. Which is the same, good question, which is the same as, because you're, that's a good question. Come on, Pin. This would be the same answer as this. Those are two ways to say the same thing. Do you see that? Because Abraham's question is good, and he's saying, well, look, Miss Aaron, right here, the fifth root was on everybody, so why didn't you just put the 1/5 on everybody? I could have written it this way. This is the same as this. I just put it on everybody individually. This means it's on everybody corporately. Same thing. Well, how do you know? Because if I was to, remember these have 1 powers, and powers outside parentheses do what? Multiply, and I'd be right back to that, wouldn't I? There are two ways to say the same thing. So you can either put the, and the math Excel may have, put the 1/5 out here with parentheses, then it's on everybody, or you can just literally put it on everybody one at a time. Either way, it's on everybody, isn't it? What would be wrong, what would be not true, would be to go like this and just put it like that. See how then it's just on the Z. If there's no parentheses at all and it's not on everybody, then it's just not on everybody. It's only on the Z, and that'd be wrong. You can either put parentheses in the 1/5, that means everybody, or you can actually put it on everybody individually. Both those are right. Good question. All those rules making sense? Okay, good. So we have the 5th root of 6x to the 6th y, all to 11. They want fractional powers again. So what do we do with that 5 in the hook? Scooby-Doo. 6x to the 6y, 11. Can I write it that way? No, I need parentheses, huh? To say that fraction power is on everybody. That good? So they're saying, get rid of the root, change it to fractional powers. So we did. So now we're going to have two things going on. Negative powers and fractional powers. Okay, first off, remember what negative powers do? So this is going to become 1 over 125 to the positive 1/3. So remember that negative powers, this is a negative 1/3 power here. I don't know if I made that clear. Negative powers, do you remember the rules for? So we have two different rules going on now that you got to keep straight. Negative powers flip things to the denominator, then become positive power. Tracking with me? So that negative power flips it to the denominator and then becomes a positive power. And now, what does the 3 do? Scooby-Doo. Cube root of 125 to the 1, but I don't need the 1. Put a 1 there if you want, but the 1's not going to do anything. Cube root of 125, use your calculator. It's 5 times 25. 5, 5. 3 5s in. 1 5 out. 1/5 is the answer. Right? Because there's 3 5s in the denominator. Sends 1 5 out. Because this is a 3 for one deal. 3 in the hook. That makes sense? Somebody see that? Good. Or you could just type it on your calculator. 125 to the power negative 1 divided by 3. And hit the equals button. And it'll be 1/5. It might tell you 0.2, which is the same as 1/5 fraction. If you change to fractions. Is that good on that? So negative powers flip things. Fractional powers root things, don't they? So 6x to the minus 1/4. Same thing, they want me to rewrite it, you know. Oh, they just want positive. Yeah, you got to read the instructions. They change their mind. Positive powers. They don't want radicals or roots. They don't want that. They just don't like negative. They just want positive. So what do negative powers do?
Go to the bottom.
Jump to the other side, flip to the other side. Now let me ask you this though, let's be clear. That negative 1/4 power, who's he on? Is he on the 6 and the x or just the x? Just the x. So who's flipping? Just the x. 6 is like, I'm not going anywhere. I don't got a negative 1/4 power on me. I'm just 6. I'm just sitting here. But the x will go down and then positive, and that's our answer. Does that make sense? Because that power was never on the 6. It will not affect the 6. That negative 1/4 power was only on the x, so he makes the x jump, and then the x becomes positive. On that, yeah?
It was like 6 minus x with the whole thing have to flip because it's attached.
6. Oh, no, it wouldn't be attached in that way. Yeah, that's a longer story. Yeah, it's not that firmly attached. I know, there's levels. Yeah. If there are parentheses, though, if there are parentheses, then the whole thing would go down. Because then that power would be on the whole thing. But there were no parentheses, so that power was only on the x, so only the x jumps. So what do negative powers do? Whomever they're on, they make that thing jump to the bottom, and then that power, notice, becomes positive after the jump. It's like they're unhappy. That's the analogy I always make. They're negative. They're unhappy at their job. They want to jump to a new job. Then they're happy. Then the power becomes positive after the jump. So that power there, 20xy to the minus 7. So that negative power is going to make jump. What's that negative power on now? Is he on everything or just the... He's on everything, clearly, right? So that means everything is going to jump to the bottom and become positive. So what's left on the top? Just a 1. Does that make sense there? Everything jumped to the bottom because the negative power was on everything. So negative powers make whatever they're on jump, and then the power becomes positive. And they're happy. They're unhappy where they're at. Now they're happy after the jump. Okay, so 3x over 2yz to the negative 7. So what's that negative power? Good. Now, who's the negative power on this time? Well, everything, the entire fraction. So it's going to make everybody, the 3, the x, the 2, the y, the z, everybody is going to jump from where they're at to the other side. So really, the whole fraction is just going to flip, isn't it? And then after the flip, the power changes to positive. So that's it. Just flip the thing, make the power positive. So negative powers make things jump, and then they become positive. Don't they? Whatever they're on. And it was on everything this time. So everything jumped. Everybody was unhappy at their job. They all traded jobs, now they're happy. That's what basically happened. Is that good? So, negative power. Again, they want positive powers. So what's that negative power going to do? He's going to make it jump to the top. So this one's unhappy on the bottom. He'll jump up to the top and then become happy, positive. And you can put a 1 on the bottom if you want, but we never leave 1s on the bottom, do we? We leave 1s on the top. We never leave 1s on the bottom. We never leave 1s on the bottom. Because 7 over 1 is just 7, right? It's just dividing. 1 divides into 7 times. We never leave 1s on the bottom. But 1/7, you can't say that's the same as 7. 1/7 of a pi is not 7 pies. So 1s in the top must stay, right? 1s on the bottom vanish. These are getting repetitive. Same thing every time. So 2 to the minus 3/5, x to the 3rd, y to the minus 2/3. Same thing, they want positive powers. So who has negative powers on them? The 2 and the y. Whereas the x is good. He's going to stay right where he's at. The 2 and the y will jump down. Jump down. So the x to the 3rd stays up. The 2 jumps down, positive 3/5. The y jumps down, positive 2/3. Done.
Oh, you don't have to do anything anything special to the number?
Nope, nothing, because you can't clean that up. You tried to calculate it some ugly decimal. Just want you to leave it that way. No messing with it. Does that make sense? So just the negative powered ones jump. The others stay put. Right, we're right here at the end. There must be review. So I remember these at the end. So yeah, 3/5 times 5 to... What is the rule? What if you had like 5 to the second times 5 to the third? What's the rule there? What do we do with the powers? Add them, huh? So same thing here. I got to add these powers. So how do you add 3/5 and 1/10? Common denominator. Multiply top and bottom by 2. 6/10 plus 1/10. 7/10. So this is 5 to the 7/10. Gotta get it. Coming up. What's that?
It's not 25?
No. Look up here. Was this 25? Remember, you don't actually multiply the bases, do you? Really good question. Everybody see that's an important rule. You don't actually multiply the 5s and get 25, huh? You just add the powers. You don't multiply the 5s. Really good question. Okay, well, we did good. We're gonna that's